Okay, so now that we've got, excuse me here, now that we've got, we did sine and cosine separately. Today we're going to focus on tangent. So what I'm going to do is, you can see here that cosine and sine, that's what we figured out the day before. Sorry, I got some water here. We figured out that the x-coordinate at each of these values represents the cosine of a particular angle in degrees and radians, and now we're going to do tangent. Now what I'm going to do is I'm going to actually kind of like talk through the pattern that I have in my head that I shared with you yesterday, but I'm going to quickly fill this out because the idea here is that you can do this with speed. So keep printing this out and keep practicing because, man, if you've got these 64 values here all put together in a framework, it's great. It's tremendous to have at your fingertips. Okay. All right. So I'm gonna go with the degrees first. I got 0 and I got 360 degrees. Then I have 30. I get 45. Then I got 60, 90, 120, 135, 150, 180, 210, 225, 240, 270. To 300, 315, and 330. Okay, I got the degrees. Now I'm going to do the radians. Okay, so I know this is 0 degree radians. I know this is pi. I know that this is 2 pi. If I go again, then I know that this is pi cut in half, and this is actually 3 half pies. Okay, and then what I do is I go to the pi over 4s. These are the very convenient ones for me. I know it's 3 pi over 4s. This is 4 pi over 4, so this is 5 pi over 4. This is 6 pi over 4, so that's 7 pi over 4. Okay, and then I go to the pi over 3s. So pi divided by 3 is actually 60 degrees. This is 2 pi over 3. This is going to be, that's 3 pi over 3. This is 4 pi over 3. That's 5 pi over 3. And this would be 6 pi over 3, which is 2 pi. Now I've got the pi over 6. This is 5 pi over 6. This is 7 pi over 6. And this is 11 pi over 6. Okay? So I have that memorized because I understand these are part of families. There's either pi over 3s, pi over 4s, pi over 6s, or pi over 2 families. Okay? Alright, and now I remember that cosine actually is, let's do this in a different color here. I know that cosine starts at radical 3 over 2, okay, and then I go radical 2 over 2, and then 1 over 2, alright. I do the same thing over here, but over here he is negative, okay. Now going down here, I know that he is also negative, okay, and then over here he is now positive, so radical 3 over 2, radical 2 over 2, and 1 over 2. So notice that what happens is you start at the x-axis and then count down on the cosine. X-axis, count down. X-axis, count down. So that's cosine. Now I'm going to switch colors and do the sine. Sine is going to go the other direction. He's going to actually count up. Okay. In this quadrant, they're actually both positive. Okay. So I count up. He's still positive. Okay, so here, count up. Now he's negative. Okay, so remember, this is why we call it cosine, a complement sign. They basically kind of just tag team each other. They just go back and forth with each other. All right, here we're going to go to sine, and then this guy's negative still, so he counts up. And everything is always radical something over 2. And just don't put radical 1 because it's the square root of 1 is just 1. Okay, so again, that's just from complete memory because I recognize the pattern. Now I'm going to go ahead and do the major ones here. I'll do these guys in brown. This x-coordinate is 1, 0. This guy is 0, 1. This guy is negative 1, 0. And this guy is 0, negative 1. Alright, and those are just coordinates on the xy axis. Okay, positive over here, negative over here on your x's, positive over here, negative on your y's. Alright, so that's essentially what we executed yesterday. Alright, and I did that in about 4 minutes. Now hopefully you can do this in 2 minutes, about half the time without having to explain it. Just go bam, 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 bam. All right? Okay. Now, what we want to do is we want to focus on tangent. Now, if you remember, I left the notes down in the basement. If you remember that I gave you a definition of tangent beyond just O over A, okay? We know that TOA is opposite over adjacent. But I want you to kind of look at this. Oh, sorry, that should be H. Okay, here's sine, and this is cosine. Now, if you notice, these H's would actually... Oh, sorry, my fault. Try that again. O over H over A over H. Now those H's are going to actually cancel out if I were to divide a fraction. Okay, so you see that you get O over A. So what this guy is here is the sine of an angle. Okay, we'll just call that theta. Tangent is also sine over cosine. So what that really is, okay, if you look at this, now notice we have this little blank spot here. What that means then is if I take the y coordinate and put it over the x coordinate, I have tangent. So I take these guys, and if you do enough of these, you'll just start to remember the values. They're all going to either be square root of 2s, square root of 3s, you know, 2s. You'll see that there's only a certain amount of values that you're going to have for these. It's just a handful, really. So what we want to do, and what I'm going to use this space for, is we're going to calculate those values. Because if I do this tangent over here, these three, then all of the other ones are going to fall into place. I know the other ones because these are all the same values, here, over here. So I really only have 3 different types of fraction, 3 different values that I'm going to have here, and then I'm just going to determine whether or not they're positive or negative in each location. Okay? So just remember to put the y coordinate over the x coordinate. Now, I'm going to do this actually in black again. Okay, so tangent, you can see here, y over the x, tangent. Okay, so y coordinate is 0, okay, and so this guy is 0 over 1, okay, sine over cosine, sine over cosine, so that's just 0. So it looks like the tangent at 0 degrees is 0, all right? Now I'm going to do these easy ones first. Now here we actually have kind of an issue here because we have the sine over cosine, and you cannot divide by 0, so what we do is we call that undefined, okay? So he's undefined there. Which, that undefined, actually, when you graph tangent, it creates an asymptote here because you cannot divide by 0. Okay, now we'll graph tangent, that's next week. Okay. Alright, so now we go here. So this is going to be 0 over negative 1. Doesn't matter that it's negative. It's just going to be 0. So tangent is 0. What's up, buddy?
There's a real game of doing fixing the neighbor that was in Hello Neighbor. You have to take his heart out.
That's gross. Oh, you're not watching that video, are you?
I did.
Okay. Well, don't watch that. That sounds bad.
Well, it's on the Xbox One.
Okay, all right, we'll change it. Taking advantage of me making videos, so he's watching some gruesome Hello Neighbor video. I don't know how gruesome they can get, but I don't know. They watch weird YouTube stuff. Okay, so these guys, whenever your cosine is 0, it's going to be undefined. So when we say the tangent of 3 pi over 2 is undefined, the tangent of 0 is 0. The tangent of pi over 2 is undefined. The tangent of pi is 0. All right, these are just labels. They're definitions. Okay. All right, so now here we get a little bit stranger here. Here I have the sine over the cosine. Okay, so I'm going to just use this. I'm not even doing sine or cosine here. The sine is 1/2, and I'm going to divide by radical 3 over 2. Okay. Now, you notice that the 2's actually cancel out, and I have a 1 over radical 3. But I'm not allowed to have radical 3 in the denominator. So whenever this happens, make sure, and you only have to do this once. Okay? If you're going to multiply both of these by radical 3 to get rid of the radical 3, remember this is a skill that you should have from the last unit. All right, you should have radical 3, and this will be radical 9, which is 3. So anytime you get 1/2 over radical 3 over 2, your answer will be radical 3 over 3. All right, so right here at the pi over 6 families, okay, all these pi's over 6 are going to be radical 3 over 3. And the question is it positive or negative in each one? Here, both the sine and the cosine are positive, so he is positive. Over here, cosine is negative, which makes the whole thing negative. All right? When an odd number of values are negative and they get multiplied together, it produces a negative product. So this guy is now negative radical 3 over 3. Now over here is different because now they're both negative, so that actually produces a positive. So tangent is positive radical 3 over 3. And then over here, because remember this is going to produce 1/2 over radical 3 over 2, this one will produce a negative because only sine is negative. So this is negative radical 3 over 3. Okay? Okay. Now the next one is actually simple here. Going up, we have radical 2 over 2 over radical 2 over 2. It's beautiful. They cancel out everything. So it doesn't cancel out to 0. It cancels out to 1. All right, so the tangent of 45 degrees is 1. The tangent of pi over 4 is 1. Okay, so over here at 3 pi over 4, it's 1. But since one of them is negative, it is a negative 1. Down here, tangent here, they're both negative, so it's both positive. Well, tangent is positive. Over here, only one of the signs is negative, so this will be a negative 1. Okay, and now actually the last one is, let's put radical 3 over 2 over 1/2. So radical 3 over 2 over 1/2. Now this one's easy because the 2's actually cancel out and you are left with radical 3 over 1, which is just radical 3. So he doesn't even have a fraction and he will remain radical 3. Okay, so radical 3, he's going to be radical 3 over here, but because one of your denominator here is negative, he ends up being negative. So notice that tangent is always negative here. Okay. All right, and then coming to here, they're both negative, so they will be positive, radical 3. And then one of them is negative, so this will end up being a negative radical 3. So all of these values here can be sprung from the memory if you recognize the pattern. Now mentally, tangent, I always do have to just do a little step to kind of remember. Okay, I always like do this so I remember that it's radical 3 over 3, but it never changes. It's always the same. And I've seen some students that just memorized it. Like they didn't even, they're done with the pattern. They've done the pattern so much that you could just say tangent is 60, and then bam, they're going to say radical 3. You know, they're just going to know it. Okay, so that's that. Is there anything else I wanted to, well, I guess the only thing that I could kind of point out is that we can draw like a little graph here. Okay, so you can see that the sine, how do I want to do this? Okay, I want to do it like this. Here's quadrant 1. Okay, quadrant 1 basically is positive, positive, positive. Cosine, sine, and tangent are all positive. Over here, okay, over here, your cosine is negative, your sine is positive, and so your tangent is negative. Here you have a negative cosine, a negative sine, so your tangent is positive. And then over here you have a positive cosine and negative sine, so therefore you have a negative tangent. Okay, so that's kind of the pattern for the unit circle. All right, and this thing is absolutely invaluable to you as you move forward in mathematics for all kinds of advanced engineering. Not even advanced, basic engineering requires these basic from memory type skills. Okay, all right, so that's the video for today, and now you can actually do your mazes, which I actually put in the classroom yesterday. Okay, all right, if you have any questions, feel free to email me anytime, and if you want to do a Google Meet, like I can do a problem with you, so just email me, we'll set a time up, and then we'll just meet, and you don't even have to see my face, you can just see my worksheet. Okay, so it doesn't, we can work with this. All right, have a great afternoon.